Hello, Algebra students. This is our first lesson for Unit 5. The name of this lesson is Growing and Growing. And so you can tell by that title, right? We're going to be looking at different situations that grow in different ways. To get us started and a little bit more familiar with the concept we're going to be looking at, I have this warm-up question for you. Again, go ahead, pause this video. Make sure you're pausing these videos to get these practice problems in. It really helps you learn and understand the material even better. So pause this video, try this warm-up question, and then come back to check out the answer. All right. Our warm-up question was about bacteria, and we are told there are some bacteria in a dish. Every hour, each bacteria splits into 3 bacteria. In number 1, we're given this picture here. It says this diagram shows a bacterium. That's 1 bacteria. In hour 0, so hour 0 is like our starting point. And then what happened to that 1 bacterium in the first hour. So the second picture here is hour 1. Our job is to draw what happens in hour 2 and hour 3. I'm going to scroll down here to get a little more room for my picture. So the information I need to use is that every hour, each bacteria splits into 3 bacteria. So that means this first one right here would split into 1, 2, 3 bacteria. The second one right here would split into 1, 2, 3 bacteria. And then this third one right here would split into 1, 2, 3 bacteria. This picture that I just drew here would be our 2. This is our 1 and our 0. This is hour 2. I need to also draw what happens in hour 3. Before I draw that, I'm just going to do a quick running total at the bottom. In hour 0, our starting point, we have 1 bacteria. Hour 1, I have 3 bacteria. And then this picture here, I have 3, 6, 9 bacteria. Any idea how many I'm going to end up having in hour 3? There is some math we can use here. For each of these 9, it's going to turn into 3. So this first one, 1, 2, 3. My second, my third bacteria, my fourth bacteria, my fifth bacteria, my sixth bacteria, my seventh, 8, and 9. And so if we look at the screen here, I have 3, 6, 9, 12, 15, 18, 21, 24. I have 27 there. Do you see what math we could use? Each time we are multiplying, the 1 that splits goes into 3. So every single time we are multiplying by 3 to get that next hour there. And so you can definitely draw the picture. The question asked you to draw what happens in hours 2 and 3. But our picture is showing that multiplication relationship here. Number 2 is just asking how many there are. So hour 2 would have 9, hour 3 would have 27. If I had asked you about hour 4, for hour 4, I would not want to draw it, but you might be able to see now what math we would have to do to get to hour 4. Hour 4, I would be just taking hour 3 and multiplying it again. And so in our lesson today, there's going to be some multiplication, and the relationship, the situations we're looking at are going to be similar to this one about bacteria. I had mentioned earlier, this first lesson here is all about how different relationships are growing. And so our objective for this first lesson is to compare growth patterns using calculations and graphs. The story we're going to use today to help us understand this new relationship we're looking at in this unit is this one about a genie. We've got, you are walking along a beach and your toe hits something hard. You reach down, grab onto a handle, and pull out a lamp. It is sandy. You start to brush it off with your towel. Poof! A genie appears. He tells you, "Thank you for freeing me from that bottle. You can choose one of these purses as a reward." Feels like English class. We're getting this nice story here. So we've got a genie, and he's giving us 2 options for a reward, 2 money options. The first option is to take a purse, which contains $1,000 today. And if you leave it alone, meaning you don't take any money out, it will contain $1,200 tomorrow by magic. The next day, it will have $1,400. And this pattern of 200 additional dollars per day will continue. When I read over that option in class, a lot of students are like, oh yeah, I want that one, right? $1,000, getting $200 every day. That is a lot of money. Purse B, which contains 1 penny today instead of $1,000, but leave that penny in there because tomorrow it will magically turn into 2 pennies. And the next day, there will be 4 pennies. And the amount in the purse will continue to double each day. Real quickly, I want to talk about that word double. When something is doubling, what math is happening there? Well, it went from 1 penny to 2 pennies, 2 pennies to 4 pennies. Doubling is when you're multiplying by 2. And so we are given this option. I really encourage you, looking at these two options, which one interests you? Which one would you want? I think there are different reasons to choose each of them. I've had a lot of students, like I said, who like purse A for the $1,000, but maybe you want purse B. Maybe you have a plan for that purse. We're going to look at the situation a lot in this lesson, and so keep in your head which one you think is the better option, and then we will revisit that question at the end of this lesson. So there are two options again at the top of the screen. The first thing we're going to do is calculate how much money will be in each purse after a week. Now we are told this first one starts with $1,000 and we're adding $200 each day. The second option starts with a penny and that we're doubling that penny each day. Go ahead and pause this video and see if you can calculate the amount of money in each purse after a week. To get us started with these calculations, I went ahead and I put the information we were given on the screen. For that first purse at day 0, so that starting point, we have $1,000. And purse B on day 0, or that starting point, starts with a penny, which I rewrote to look like $0.01. Our first purse A, is increasing by $200 each day. So after the first day, I would add $200. After the second day, another $200. Day 3, day 4. We're going to a week, which is 7 days. So I'm going to need 4 days. Day 5, day 6, and day 7. Now, you could have written it like this. There is an easier way to write out all of these $200. You could have also just said we're starting with that $1,000 and we are going to add 200. We're going to add 207 times and written it like that. Either way you do it, that is going to give you the $1,000 we start with, plus all of those 200s add up or multiply to give you $1,400. And so after 1 week, that purse is going to have $2,400 in it. That is a lot of money. For our second purse B, remember that penny is doubling every day. So it doubles the first day and doubles the second day and doubles the third day. And 1, 2, 3, 4, 5, 6, 7. It's going to double every single one of those days. When we do this in person, I have some students who calculate what the result is after each of those and do it that way. I'm just writing out the key math we're going to have to do for 7 days. So we're going to take our penny and we need to double it 7 times. Similar to purse A, I could write it out like this, but there is an easier way again to write all of those multiplying by 2s. I'm taking my penny and I'm multiplying it by 2 7 times. And the way to show 2 times 2 times 2 times 2 times 2 times 2 times 2, the way to show times 2 7 times is using that exponent. Since there are 7 of those, I'm going to use the exponent 7. 2 to the 7th power means 2 times 2 times 2 times 2 times 2 times 2 times 2. When we go to do this math, again, you could take your penny and double it and get 2 pennies, double it and get 4 pennies, double it and get 8 pennies, and so on to get that result. Or I can go ahead and I'm going to use PEMDAS to help me out. It says I should calculate my exponent first before I do that multiplication. So I'm going to figure out that 2 to the 7th power equals, give me a second, 2, 2, 4, 8, 16, 32, 64, equals 128. And so 128 times our penny is going to equal a grand total of $1.28. Per se is looking quite good. I would much rather have $2,400 than $1.28. This was us calculating after 7 days. I'm going to give you another chance to try doing that math again. This time we are going to calculate after 2 weeks. Again, pause this video, and especially now that we've done the calculation for 1 week, I'm going to leave it up there at the top. See if you can use that calculation to help you calculate how much money is in each of those purses after 2 weeks. Pause the video now and try that. Even I paused the video so I could do the math and have it ready to go over. For purse A, using those calculations we have above to help me out, purse A, again, we know is starting at $1,000, and we are adding $200 each day. And so if I'm talking about 2 weeks, I'm using the fact that 2 weeks is 14 days to know that I need to add that 214 times. Now, earlier we wrote it both ways. I am not going to write plus 200, plus 200, plus 200, plus 214 times. I'm just going to go ahead and say I need to add 200 times 14. Now, I'm going to do that multiplication first before addition. That also goes back to PEMDAS, order of operations. And so when I do that multiplication, it gives me $2,800. And so for per se, we have a grand total of $3,800. Still looking really good. I would love that much money. For purse B, just like we said above, purse B is starting at that penny, and we are doubling it. We are going to double it 14 times. And so multiply by 2 times 2 times 2 times 2, 14 times is the same thing as multiplying by 2 to the 14th power. Again, I'm using PEMDAS to know I need to do that exponent first. And when I do all of those times 2 times 2 times 2 times 2, 14 times, it gives me the number 16,384. And when you do 16,384 multiplied by 1 cent, you get a grand total of $163.84. So it's starting to become a good amount of money, right? But per se, I'd still rather have per se. We're going to do this one final time. This time, I want you to think about a month. And a month we're going to call is 30 days. Which purse would contain more money after 30 days? Pause this video one last time to do that calculation and then come back to check your results. And I will pause now too. All right, I got my answers. For purse A, just like for all of these, it is starting at $1,000. And we are going to be adding $200 30 times. That means that $1,000 that we start with, we are going to be adding $6,000 to it over 30 days. And so purse A is going to end up with a grand total of $7,000. For purse B, we are taking that penny we started with and we are doubling it. We are doubling that penny 30 times. So I'm multiplying it by 2 to the 30th power. That means 2 times 2 times 2 times 2 times 2, 30 times. When we do that, it means after you double it 30 times, it means that penny is going to be multiplied by 2 to the 30th power, which equals, are you ready? 1,073,741,824. And when you take that number and you multiply it by a penny, you get, let me copy all these numbers. 8, 2, 4, 10,741,824. $737,418.24. Oh my goodness. What happened with purse B? Purse B was that one that just started with a penny. And look at some of these numbers we had early on. It started with a penny. That penny on day 1 turned into 2 pennies. Day 2, it was 4 pennies. Day 3 would have been 8 pennies. At the end of a week, it was only $1.28. At the end of 2 weeks, halfway through a month, right? It was at $163.84. Purse A was looking good for so long. But then here, oh my gosh, it's not even a contest. Purse B has so much more money. So what is going on here? To help us understand this situation just a little bit more, the second part to this is let's look at a graph. We love graphs because it's that visual, right? You have a picture of what's going on in the situation. So here we have 2 graphs. And it says, here are the graphs showing how the amount of money in the purse changes. Remember, purse A started with $1,000 and grows by $200 each day. Purse B starts with a penny and doubles each day. I'm going to have you go ahead and look at this graph for a moment. And my first question is, can you figure out which one is purse A and which one is purse B? Is it the blue line for A or the red line for A? Take a moment to think through that now. Purse A was the one that starts with $1,000 and is growing by $200 each day. And so there's a variety of strategies you could use to know that this red line here, this is our purse A. One way is to look at the starting points. Notice that the red line starts higher than the blue line. And so that must mean purse A is going to be the line that's higher because it starts with more money. Another way you can use this information to help you identify purse A is that red line, is because remember we said it was growing by $200 each day. It is increasing by the same amount each day. So notice if I look at that line, it's going up the same amount every single time, every single day. Whereas purse B must be this blue line because for one, it starts lower. It starts off lower, and purse B started with less money. And then notice this line is really low for a long time. And that matches up with some of the calculations we did until about here it starts increasing a whole lot. So looking at that, I'm noticing it's not like purse A. It's not going up the same amount of money every single time. And when you double something, it's not going to go up the same amount. Remember, even at the very beginning, from our starting point to day 1, it went from 1 cent to 2 cents. So it went up 1 penny. But then 2 cents doubled is 4 cents. It went up 2 pennies. 4 cents doubled is 8 cents. So it went up 4 cents. It's not going up the same amount of money every single time. Using this graph here and the fact that the red line is purse A and the blue line is purse B, I have some questions for you. The first one is we've got these 2 points right here, P and Q. Go ahead and think through what those 2 points would mean. I'll give you a moment now. Let's start with point Q here. Point Q is on the red line, so I know it's telling me something about purse A. If I look at the 2 numbers on our X and our Y axis, point Q is here at the number 5, so I know it's talking about day 5. And if I come over to my Y axis, it looks like it's at this line right here. And it might take a little thinking, but knowing that this 5th line is at 10,000 helps me know that each of those lines is going up by 2,000. 2,000, 4,000, 6,000, 8,000, 10,000. If you just think about the 10, it helps a little bit. 2, 4, 6, 8, 10. And so the point Q is telling me the amount of money in purse A at day 5. The amount of money Day 5, that would be in purse A, is $2,000. Point P is right here. And similarly, point P is on this blue line, so I know it's talking about purse B. It is at day 9. In this graph, the scale on my y-axis is so big, it's really hard for me to estimate how much money is there. I might have to actually do some calculations to figure out the exact amount. But point P would be telling me how much money is in purse B after 9 days. Looking at that same graph, the third question is, what are the coordinates of the vertical intercept for each graph? And remember, vertical intercept is the one we're usually calling our y-axis. So I'm looking at my y-axis to find the y-intercept or the vertical intercept. Go ahead, pause the video on this one and try this one here. Looking at our graph, I may think I need to estimate where these points are on our y-axis, but we actually know them from the story. Those points on your y-axis are the starting amounts. And so here, I know that purse B is starting at 1 cent. So that would be my vertical intercept for the blue line or for purse B. And my red line, right? Like I could try to estimate what number that is, but I know that purse A had started at $1,000. And so purse A, that vertical intercept or that y-intercept would be at the number 1,000. Remember, your y-intercepts always represent that starting point. Okay. 2 more questions with this graph. Number 4 says, when does purse B become a better choice than purse A? If you think about those calculations we had been doing, remember that first purse started with $1,000, was going up $200 each day, and it seemed like such a good option for those first couple problems we did. It wasn't until the very end that we realized purse B, if you wait long enough, right, really is a good option. So this question is about, when does it become a better option? When does purse B become a better choice than purse A? Well, it becomes a better choice than purse A on that day where B has more money than A. And so looking at our graph, A is more money. I know that because it's above B. More money, more money, more money, more money. It's not till right here at this day that notice that blue line is just a little bit above A. And that would be on day 19. So after day 19. Now on day 19, it looks like they're really close, but shortly after that, right, is when purse B starts having more and more money. And notice I can't even see how much money purse B has after day 22 because this line is going up so much, it can't fit on this graph. We had seen at day 30, right? Remember, it was, what was it? Was it 10 million? Yeah, $10 million. And that does not fit on our graph here. That only goes up to $42,000. And so day 19 is that day where it becomes the better option. So knowing everything we know now, which purse would you choose? Well, usually in class when I ask this question, most people say purse B because we saw purse B ends up having a lot of money. But sometimes students bring up a good option of, well, how long do we get the purse? And I think that's a really good question to ask, right? We just said purse B is only the better option after day 19. So if you're allowed to have that purse forever and you can wait 19 days to take out the money, then absolutely B is going to be better. But if you only got that purse for 2 weeks or 1 week, right? We saw for the shorter amount of time, A is a much better option. So I think a reasonable answer is it depends, right? How long do we get to keep it? If the genie comes back, in a week and takes it away from us, I would definitely be going with A because after a week, A has more money. But I think based on the way the story is written, it seems like there's no limit to how long we could have it. And so if that's the case, I would be choosing purse B. Before we jump into the summary of this story, I want to talk about the direction this unit is going. Looking at these two graphs, one of these graphs here should seem more familiar to you, and that is the graph of A. Back in Algebra 1A, we spent an entire unit talking about equations and situations that look like A. Remember, the math we were doing every single time for A was we were saying it starts at $1,000 and we were adding $200 for each day. And I'm just going to put a variable there. That gave us the total amount of money. Looking at that equation there, that looks exactly like the equations we had talked about in pre-algebra and Unit 2 about linear equations. Purse A right here is an example of equations you've already seen before. This is a linear equation. Those linear equations are those equations that describe relationships that increase by the same amount. Here, that line is going up $200 each day. The slope is 200, and that tells me it's going up $200 for every one day. We spent a lot of time talking about linear equations. But this blue line here, that's not a linear equation. Notice the line is curving and it's not a straight line. Linear, we said, comes from the word line. Also, when we think about those calculations we were doing, it started with a penny, but we weren't adding a number each time. We were multiplying by 2. We were multiplying 2, and it depended on how many days that had gone by to decide how many times we multiplied by 2. We were putting however many days right there as our exponent. This math right here does not look like our equations we had looked at with linear equations. This is a different relationship. And so that different relationship is what this next unit's going to be all about, is exploring this new way, this different way that relationships can grow. We've talked about relationships that grow by the same amount every single time, but this new idea of a relationship doubling or tripling like the bacteria did in the worm-up, this idea of a relationship growing with multiplication is this new one we're going to explore. So in summary, we have noticed in this lesson when we repeatedly double a positive number, it eventually becomes very large. Thinking about that penny that we were doubling again and again and again, given enough time, it becomes a whole lot of money. Even if you start with a smaller number, so 0.001, that is so much smaller than a penny. Even if you start with something super, super small, when you double a number again and again and again, it does start to get bigger. And in this table, it doesn't look like it's getting very big, but with enough time, it does. If we were to continue this process, we learned that an exponent is really helpful. I can write that I'm doubling that 0.001 4 times by showing times 2, times 2, times 2, times 2, but it's a lot easier to use an exponent and just say we're multiplying by 2 4 times. And even though we started with a super, super small number, you don't actually have to double it that many times to reach a very large number. So for example, if we were to take that 0.001 and double it 30 times, you still get a result that is greater than 1 million. This whole unit, throughout this, we're going to look at a lot of different situations where quantities grow or decrease by applying the same factor repeatedly. Factor means we're talking about multiplication. Thank you so much for watching this video. I hope you found it helpful, and I will see you in the next one. Bye, y'all.